Hey kids, we are back with another video lesson. So your notes should look like this. We are locating midpoints and other points on a number line, maybe. Computers are being a little slow here. So just hang tight real quick. How's everyone's day going? Hope it's going great. Okay, so this is what your notes should look like in your binder or wherever you are keeping them. So now I'm going to bring them to my screen so we can get started. Okay, so after today's lesson, you will be able to find the midpoint of a segment, and then you will also be able to locate a segment given a fractional distance from one of the endpoints. The first thing, finding midpoints, is very simple, very easy. This second part, though, is a little more tricky, but it's not too terrible once you get the hang of it, okay? So here we are, folks. It says the midpoint of a segment. The midpoint of a segment is halfway between both of its endpoints of that segment. Well, duh, like think of the word midpoint, guys. Like mid kind of makes you think of middle. It's a point, so it's the middle between the two endpoints of a segment. Given this picture up here, if M is the midpoint of AB, then AM is equal to MB. Whoa, sorry guys. Okay, let's break that apart for a second. So what is that telling us, or why do we care? So if M is in the middle of AB, then this distance here from A to M is the exact same length as M to B. And that should make sense, right? Because it's in the middle, it should be directly in half. So that makes sense, right? That this chunk here is the same distance as this chunk here. So right here, it's saying that their lengths are the same. And then it's saying the actual segments themselves are congruent. So segment AM is congruent to segment MB. Again, one of those weird technical things we do in math. They basically mean the same thing here, but they're just their notations are different. So let's try kind of more simple example here of finding the midpoint. So it says the temperature on a thermometer dropped from a reading of 25 degrees to -8 degrees. Find the midpoint of these temperatures. What is our game plan? There's a few different ways you could do this. How my brain works is I'm thinking, if I use this thermometer here, I'm at 25 degrees. And then I need to get down to -8. And I want to find the middle of these two numbers. Okay. So, I mean, if you really want to use your fingers, you can count. That would work. But to me, that doesn't seem very efficient, right? So I'm going to find the distance between these by subtracting. So I'm going to take 25 minus -8. But we all know that subtraction means to really add the opposite. So 25 plus 18, plus 8 is what, folks? 33. So that's the distance from here to here is 33 degrees. Now I need to cut that in half because I want to find the middle. So 33 divided by 2 should give me what? 16.5? Yeah, right? So now from here, we have to go 16.5 degrees in one direction. So let's see here. So if I take 25 and subtract 16.5, what do we get? You should get, my brain's not working, guys, so 8.5 degrees. So that is the midpoint between 25 degrees and -8 degrees is 8.5 degrees. Now there is more than one way to do it. That's how my brain thought of it. You do you, and you should be good to go. So we have a formula to use called the midpoint formula when we are on a coordinate plane. So when we're not just on like a number line, like it's easier to count, right, when we have this. But if we were like on an XY plane and I wanted to find the midpoint of this segment here, It's not as easy as just counting. We actually can use this formula. So what is this formula? Well, you're going to be given two ordered pairs, and one's going to be x1, y1, and the second one is going to be x2, y2. From there, what you're going to do is you're going to take your x coordinates, add them together, and then divide it by 2, because we're finding the average at the middle, right? So we're dividing by 2, and then we're going to do the same thing with our y coordinates. We're going to add them together and then divide by 2. And that is how we get our midpoint. So jot that down, make sure you have it written down correctly before we get started. And most of the time we use m equals, so that's how you know it's the midpoint. So very straightforward example here. It says, find the midpoint of segment ST for S is -6, 3, and T is 1, 0. So first steps first, I'm just going to label my x1, y1, x2, y2. Because remember, each ordered pair gets an x and a y. And then our formula, I'll just write down for this first one, since I don't have it on my sheet. Okay, so we're going to plug in. What did I label as my x1? Well, we labeled that as -6. Plus my x2, we labeled that as 1. And now same thing with our y's. What did we label for our y1? 3. Plus our y2, 0, all over 2. And now we just simplify. So -6 plus 1 is -5 over 2. 3 plus 0 we know is just 3 over 2. So really you could leave your answer like this if you're a fraction person. If you're a decimal person, you could simplify that out a little bit more. -5 divided by 2 is -2.5, and 3 divided by 2 is 1.5. Either way works for me. However your brain works, it's a-okay. That's it. We plugged into a formula, we added, divided, got our answer. All right, our next example here, find the coordinates of J if K, -2, 1, -1, 2 is the midpoint of segment JL, and L has the coordinates of 3, -5. So what we're looking for, you guys, is one of the endpoints. So we're missing one of our endpoints, given one endpoint and the midpoint. So this is what I like to do. I like to give myself a little picture here. So we have a segment JL, and we know K is the midpoint. So now let's label what else they give us. They tell us K is at -1, 2, and L is at 3, -5. And we are looking for the ordered pair of J. So now we need to remember, if we know the midpoint, right, we know that this is the middle. So then from K to L has to be the same length as J to K. So it's really quite simple when you think of it in terms of that, because let's see here. If I want to go from -1 to 3, like what do I do? Right? I add 4, right? I'm adding 4 this way. So from -1 to 3, I had to add 4. Well, now I need to go 4 the other way to get to J. So if I added 4 here, then I need to subtract 4. So -1 minus 4 more is -5. Are you with me? Did I lose any of you? Okay, let's try with our y coordinates. So again, what we're doing is I'm at 2, and I need to get to -5. So how do I go from 2 to -5? So 2 to -5, I subtract 7. So I went down 7. Well, I need to go 7 away the other direction to get to my y over here. So if I subtracted 7, then I need to add 7. So 2 plus 7 gives me 9. So our coordinates of J would be -5, 9. we'll do a few of those today in class, or when I have you in class to practice, because those are kind of goofy, and I realize that. Okay, we have a little algebra on this example. So it says, find the measure of segment PQ if Q is the midpoint of segment PR. Our goal is to figure out how long PQ is, right? But in order to do that, we have to figure out what our variable equals. So we need to think of an equation we can write given all this information. So some keywords here, we have a midpoint. So if Q is my midpoint of PR, remember then that means from P to Q is the same as Q to R. They're the same. So when we know things are the same, we can set them equal to each other. So let's look here, folks. I can set PQ equal to QR because these two things have to be the same. And now we can plug in. What is PQ? Well, PQ is 9y minus 2, and QR is 14 plus 5y. And now we just have a standard linear equation that we all know how to solve. So I'm going to bring my y's to one side and my numbers to the other. So subtract 5y, add 2, divide out, and we find that y is equal to 4. But now always remember to go back and find what you're asked for. We are actually trying to find PQ, so now we got to plug in for PQ. So PQ was 9y minus 2. Plug in for y. We find that it is 34. How do we feel? Was that okay? A little bit of algebra kind of makes us feel good because we all know how to do that. All right, next up. Find the value of x if C is the midpoint of segment AB. Then we're told what AC equals and what AB equals. Again, in our class, a picture is worth 1,000 words. Let's draw it out. So C is the midpoint of AB. What does that look like? Give yourself AB here. Now we're going in the middle for C, our midpoint. So then I know that AC is congruent to CB because it's the midpoint. I'm going to repeat that a lot, so just bear with me. And now we can label. AC is 4x plus 5, and the whole thing is 78. Well, I can write an equation based on this information. It's just going to be a little different than what we've done in the past. So let's see here, folks. What is our relationship between AC and AB? So what do I know about AC from here to here and AB? Well, remember, we have a midpoint, so I know that this is in the middle or this is half. So we could do one of two things. I can double this and set it equal to 78, or I can take half of 78 and set it equal to this. Both are fine. You do whatever your little heart desires. I think I'm going to take half of 78 and set it equal to 4x plus 5. So half of 78 gives me 39. And now again, we just have a simple algebra problem to solve. Subtract our 5 over. Divide out. We find that x equals 8.5. Oops, sorry folks. There we go. And that's all it wanted. We just wanted to find the value of x, and now we're done. Good work. All right, to the back. New terminology. We love new words. This whole course has a lot of terminology, so just kind of get used to that. A segment bisector. A segment bisector is anything, so it could be a segment, a line, a plane, or a point that intersects a segment at its midpoint. So a bisector, just think of this, it cuts something in half. It splits into two equal pieces. It literally is something, and we cut it in half. That's what a bisector does. And a way to remember that, think of like a bicycle. How many wheels does a bicycle have? Well, it has two. Think of bifocals, those are glasses, like old people glasses. How many lenses do those have? Two. So a bisector is cutting something into two. It splits it into two. And where does that happen at? It happens at the midpoint. Okay, so it's kind of a weird question, but it says name the segment bisectors of segment PQ. So can we all agree that here's PQ? And our job is to figure out what things are cutting it in half. I'll give you a hint, there are four. So take a second and see if you can find all four different segment bisectors of segment PQ. So pause the video, do what you gotta do, and check back with me to see how you did. Again, there are four segment bisectors. Okay, I hope you tried. It's no fun if you just let me tell you everything. The first, I think the most obvious one cutting PQ in half would be plane A, right? Do you guys see how it's going through the midpoint? So we could say plane A is one. Another segment bisector, do you guys see line KM? It's going through it at the halfway point, so that works. So KM. What else do you guys see? Do you guys write down segment JM? That's cutting it in half. It's touching it at its midpoint. And then I think probably the most tricky one to find is actually point M itself. It is the midpoint, so therefore it is a segment bisector. So those are all four. I hope you at least got like 2 out of 4. But like always shoot for like half, right? You can do things at least halfway right the first time. Okay, this will be our last example. This one and the next one, sorry, like on this little segment thing. Actually, you know what? This will be our last one. Let's start there. This is our last example for notes, so bear with me through one more example, and we'll do the rest in class together when I see you. So it says, find x on segment AF that is 1/6 of the distance from A to F. Whew, it's kind of a loaded question. So our job is to figure out where does x fall on segment AF, so it's 1/6 of the way from A to F. So job number 1, figure out how far or how long is AF. So what is it? The distance from A to F. So we're going from -7 to 5. So -7 minus 5 is -12. But we know, can we have a length of a negative number? Nope. So we take the absolute value. Hopefully you've seen that in your algebra course, but if not, it just means take the opposite. So the positive value is 12. So there we are. We are at 12 is our length for A to F. And now I want to go 1/6 of the way from A to F. So we have to figure out what's 1/6 of 12. So 1/6 times 12, you can either punch that in your calculator if you forgot how to work fractions, or you can do it by hand. So 1 times 12 is 12. 6 times 1 is 6. 12 divided by 6 gives me 2. So now we want to hop 2 away from A, which gets me at what, -5? So x equals -5. Beautiful. Good work today taking notes. So we will finish those last 3 examples together in class because they're kind of, I still want to lose you. I don't want to make this video too long anyways. So thank you for bearing with me, and I cannot wait to see you next in class. So have a great rest of your day, everyone.